Hello, Precalc. We are continuing a 2-1 today. You should have the 2-1 day 2 notes out. We're going to be talking about rates of change. Rate of change, kind of synonymous with slope. And sandwich theorem. Sandwich theorem, another name that you might see is squeeze theorem. All right, what's going to happen is if you were to find the rate of change of a straight, a linear graph, no problem. A straight line, nice and easy to find the slope of. You just do the change in y over the change in x. If you have a curvy graph, so something like this, that kind of looks like a parabola, sort of. If you have a graph like this, and you wanted to find the slope or the rate of change of it, you wouldn't be able to find the rate of change of the whole thing because at points it's positive, at points it's negative. So, but what you can do is you can estimate it. And what you can do is for the slope, it can be estimated between 2 points. It can be estimated between, B/W is between 2 points. All right, so you can see at this graph here at point A, our y value is whatever f of A happens to be. At B, our y value happens to be f of B. When you do the change in y over the change in x, you would do, f of B minus f of A all over B minus A. And that equals the change in y all over the change in x. The triangle means change. When we're dealing with something called average speed, okay, because we're going to have some word problems, average speed is going to be where you find the change in your distance all over the change in time, okay? And so, for example, if let's say you are trying to find the average speed of a rocket between the 5 seconds into takeoff and 8 seconds into takeoff, all right? If you were trying to do that, if you were trying to find the average speed between the 5 seconds into takeoff and 8 seconds into takeoff, what would happen is your change in time, okay, t is going to be your original time. So in this case, it would be 5 seconds. H is going to be your elapsed time. So not the new time, but the elapsed time. So in this case, it would be 3, because from 5 to 8, it's 3 seconds. So those are the letters we're going to use. So our time would be calculated by doing the new time minus the original time. All right, new time minus original time, that will give you the elapsed time. Okay, and on the numerator, change in distance, we would do whatever the new distance is minus the original distance. Okay, we're going to replace these with some variables and get a very important equation here. So, new time, all right, the new time is going to be whatever your original time was, t, plus the elapsed time, h. Okay, t, 5 plus 3 will give you the new time. Minus the original time. The original time is t. And then in the numerator, the new distance would be f of whatever t plus h happened to be, so basically f of your new time, minus the original distance would be f of whatever your original time was. And we can simplify this a little bit. In the numerator, the t's will cancel out. We're going to be left with f of t plus h minus f of t all over h, my elapsed time, which hopefully that makes sense. If you did 8 minus 5, you'd get your elapsed time, 3. So this is going to be your lovely formula that you're going to use for average speed as well as something called instantaneous speed. Instantaneous speed is going to be how fast an object is traveling at a particular instant. So it's not going to be like, oh, what's the average speed between this time and this time? It's going to be, what is the speed at specifically this time? When you have something with instantaneous speed, h is going to be equal to 0. Your elapsed time is 0 because we're not doing a range of times. We'll practice both of these in the problems down here. So we've got a rock breaks loose from the top of a 200-foot cliff. What is the average speed? Remember, speed is something that can't be negative. It's not like velocity. Direction doesn't matter. Speed during its first 2 seconds. All right, first 2 seconds. So we're talking about from 0 seconds to 2 seconds in of its path or of its time falling. What is the average speed? If you remember from parametrics, when you did all of those types of problems where something was being thrown and dropped, you had y equals 16t squared. All right, we don't need the negative because we don't want velocity. We're not dealing with velocity. We know it's dropping, and so technically it would be negative if we were dealing with velocity. Speed doesn't matter, so we don't need the negative. We're going to be using this as our equation. It does not matter how tall this cliff was. The 200 is actually going to be excess information. All right, all we're dealing with basically is gravity, and we're talking about in the first 2 seconds. So we're really only going to be using this equation to help us. Okay, when you are trying to find the average speed is going to use this lovely formula here. We're basically doing the change in distance all over the change in time. And so when we do that, we're going to be basically doing f of t plus h minus f of t all over h. Well, t plus h, all right, t is your original time, 0. H is the elapsed time, 2 seconds. All right, and then you can plug it in. You're going to be doing f of, t plus h minus f of t all over h. Let's plug those in. So you're going to be doing f of t plus h, 0 plus 2 is 2, minus f of t, so f of 0, all over h, which is 2. All right, and then you can plug it into your equation. So f of 2 means you plug 2 in, you're going to have 16 times 2 squared, minus f of 0, so minus 16 times 0 squared, all over 2. All right, and then you can simplify this. You're going to end up with 32 feet per second. So that's the average speed during the first 2 seconds of flight. All right. Then we have the second part. The second part is talking about finding the speed of the rock at t equals 2. So this one's not talking about a range, it's talking about a specific time. It's not saying the first 2 seconds, it's saying at exactly 2 seconds in, what was the speed. When that's the case, you're talking about instantaneous speed. All right, instantaneous speed, I mentioned up here, is when h is going to equal 0. And we know that t equals 2. It says to do it both numerically and algebraically. Don't worry about numerically. We're just going to do algebraically for any type of problem. So what we're going to deal with is h is 0, t is 2. The problem is we cannot do it like the problem up above, because if we were to make h equals 0, it would be undefined. So when you're dealing with instantaneous speed, you're going to have to do the limit. Okay, we're going to find the limit as h approaches 0, because at 0 it's undefined. So the limit as h approaches 0 of f of t plus h minus f of t all over h. Okay, and we're going to still be using this equation, 16t squared. So t plus h and t are going to be plugged into our original equation, and then we're going to kind of simplify it. We're going to try and break this down. Some stuff will kind of cancel out. Now you could plug in t equals 2 right away. So if you want to, you could also put f of 2 plus h minus f of 2 all over h. I'm not going to plug in 0 just because it makes it undefined at the moment. And what we're going to do is f of 2 plus h, we're going to take the 2 plus h and plug it into our function. So instead of 16 times t squared, we're going to have 16 times 2 plus h squared. And then we have minus f of 2. So instead of t, we're going to put a 2. So it'll be minus 16 times 2 squared all over h. All right, and what we're going to do is simplify this a little bit. 2 plus h squared, when you multiply those together, you're going to end up with, all right, I'm continuing my limit as h approaches 0 because at almond it makes a big difference. They like their notation. It's going to be 16 times, when you multiply that out, you're going to get h squared plus 4h plus 4 minus 64 all over h. And then we can distribute the 16. So when we distribute the 16, we're going to end up with 16h squared plus 64h plus 16h I did something wrong. What did I do wrong? H plus 2 squared, you're going to have h squared plus 4h plus 4. I don't know why I put h. Sorry. Doing this in my head. So this should be a 4. I apologize. When you do 2 plus h times 2 plus h, you're going to get h squared plus 4h plus 4. I think I said that, but then I wrote it wrong. And then when you distribute, you're going to get not 16h, you're going to get 64. So plus 64. There we go. Minus 64 all over h. You'll notice the 64s are going to cancel, and then the h's are also going to cancel. So this will leave you with the limit as h approaches 0 of 16h plus 64. All right, and then from there you can plug in 0 because it's now no longer undefined. And when you plug that in, you're going to get 64 feet per second. So at that specific time, it was going 64 feet per second. All right, so hopefully that helps. I hope I didn't confuse you too much with my one little error there, but otherwise we will finish this note sheet on the next video. Thanks for listening.